Okay, ma. Good morning, everyone. So now, so today we are going to talk about the network analysis subject, that is networks, or we can call as a electrical circuits. Any name we can call this subject. So in this subject, already you know very well, around 10%, approximately 10% weightage will be there for our exam. So now, whatever percentage and all these things we are not discussing, directly we are entering into our subject. So coming to today's subject, I will take the AC fundamentals or AC circuits. What we will talk? AC circuit. Because AC fundamentals and AC circuits together will have weightage approximately 3 marks. Approximately 3 marks. It is a very good weightage, especially for our assistant engineer exam is concerned. So that's why today we are focusing on this particular subject for both JE as well as AE. And I think for JE, totally electrical circuits, DC circuits and AC circuits, 20 marks weightage will be there. And for the AC circuit is concerned, they will get around 5 marks here. Around 5 marks for JE. For AE, only for 3 marks. I can say it is 3 marks expected. Lot of topics are there. We will discuss one by one. Are you okay, ma? I think everybody is clear. Good morning, all of you. Now, I am going to talk the AC fundamentals or AC circuits. Now see here, coming to the AC circuit, only resistance alone. Resistance alone. We are supplying only resistance. Generally, what is the power formula? What is the power formula, Emma? Whenever power formula means, immediately your mind will tell P is equal to VI. And what is the current formula according to the Ohm's law? Current I is equals to V by R. V by R. Power P is equal to VI. But we are talking about the AC circuits. Whenever AC circuit means, our current formula I is equal to V by not R. What is this? Z. What is Z is called? Z is nothing but a impedance. Z is nothing but a impedance. So, what is the units for impedance? Whatever the units are there for resistance, same units will be applicable for the impedance also. It is like a resistance in AC circuit. Resistance in AC circuit. It's clear, all of you? Now, coming to the AC circuits, when you call power, if you want to write the power formula, it is not only VI, it is VI cos pi. It is VI cos pi. whenever if you are talking AC circuits, the power is nothing but a VI cos pi. It is not a VI. That is the most important point. Of course, here not only VI cos pi, some more powers are available. That is Q is equals to, that is reactive power, because inductor and capacitor also involving in the AC circuits. That's why there is a reactive elements. Hence, reactive power takes place. Reactive power will present. What is that reactive power? VI sin pi. VI sin pi. We have the active power, true power, real power. All together it is same. VI cos pi. And Q is a reactive power, where S is called as an apparent power, which is given by VI. Three powers are there. Three powers are there. So, S is equal to P plus JQ. S is equal to P minus JQ. We will talk all these things one by one. We will talk what is P plus JQ, what is P minus JQ. P is a active power, Q is a reactive power, S is a apparent power or complex power. Apparent power or complex power. Now, what we are going to talk, our subject is AC, hence we have to focus on this. Whatever current formulae, what is the power factor, what is cos pi, what is sin pi, all these things we have to discuss in our subject. Are you okay, Chana? All of you clear? Are you following clearly? Right, ma, right. Okay. SKR is given response, yes. Right, amma. Okay, Chana. Now, so what is the topic we are going to talk? We are going to talk about the resistance alone. So we are supplying the AC. We are supplying the AC. We have a resistance here. The voltage applied is here. It is a resistance R. The voltage V is equals to, V of T is equal to Vm sin omega T. V of T is equal to Vm sin omega T. It is the sinusoidal voltage applied to a pure resistor. Sir, what is omega, sir? What is omega, ma? Omega is nothing but a angular frequency. Angular frequency. The omega units are radians per second. Radians per second. And omega formula is given by 2 pi into F. 2 pi into F. Here, suppose if the frequency 2 pi into frequency, our Indian standard frequency is 50, the omega becomes like a 314. Omega becomes like a 314. How we are going to get the 314? 2 into pi value is 22 by 7, 3.14 into 50. 50 into 2 is 100. 100 into 3.14, 314. Already we written. So for example, if the F is equal to 60 hertz, F is equal to 60 hertz, what is our omega? What is our omega? Omega is 2 pi into 60. That is equal to 377. That is equal to 377. So, suppose omega is equal to 100 pi. Omega is equal to 100 pi. What is the frequency F? What is the frequency F, ma? The frequency. Actually, omega formula is what? 2 pi F. Already pi is given. 2F is equal to 100. F is equal to 50 hertz. F is equal to 50 hertz. Like that. Omega and frequency F relation we require. Omega F and frequency F is required. I hope now in this case V of t is equal to, for example, V of t is equal to 200 sin 314t. They will give like this. What is the information available from this? V of t is equal to 200 sin 314t. What is the information available from this? From this equation, we got a information, this 200, this Vm, both are same. So, Vm is equal to 200 volts. Sir, what is Vm means? Vm is nothing but a maximum voltage. Maximum voltage. What is the maximum voltage? 200 volts. How to get the RMS voltage for this? Vrms. Vrms is equal to sinusoidal waveform Vm by root 2. Vm by root 2. That's why what is Vrms is equal to? Vrms is equal to 200 volts divided by root 2. 200 divided by root 2. It is clear, ma? I hope you understand what is the maximum voltage, RMS voltage. I told you RMS voltage Vrms is equal to 200 by root 2. And what is this one? What is this one? That is a omega. Omega is equal to 314. 314 is equal to 2 pi f. Already we written there. F is equal to 314 divided by 2 into pi. That is equal to 50 hertz. That is equal to 50 hertz. Clear, ma? Omega is equal to 314. Frequency is 50 hertz. That is the available data what we are having. Please write the points. Take a notes on this one. When I am discussing, try to note down your points also. Try to note down the points also. Now, here we are given a sinusoidal voltage. Sinusoidal voltage we are given. Now, see here, voltage V of t. Voltage V of t is equal to Vm sin omega t, already given. What is the current I of t? Current I of t. My dear students, we given the voltage, we have only resistance. According to the Ohm's law, I is equal to V by R. I is equal to V by R. Based on this formula, I of t is equal to Vm upon R. Sin omega t is there. Here also we got the sin omega t. Now, what is the equation we can write here? I of t is equal to Im sin omega t. I of t is equal to Im sin omega t. Now tell me, what is the Im formula? From this equation, what is the Im formula? Just you check here. Im is equals to Vm by R. Im is equals to Vm by R. Sir, what is Im? Maximum current. What is Vm? Maximum voltage. But in our practical situations, always we will use the RMS values. What values we will use? RMS values. So, I is equals to V by R. See here, this current is a maximum current. This current is a maximum current. And what about this current, Amma? What about this current? This current is called as a RMS current. RMS current. Root means square value. This current is a maximum current. This voltage is a maximum voltage. This current is a RMS current. This voltage is also a RMS voltage. Now, what are the points which we observed here? What are the points observed in this situation? V is equal to Vm sin omega t. Current I is equal to Im sin omega t. What do we understand by these two equations? Sir, what do we understand by using these two equations? Tell me. Is there any angle here and here? There is no angle between voltage and current. There is no angle between voltage and current. In case of pure resistor, this is a very, very important for further discussion of our subject. Now, if the voltage is here, where is the current? Current is also in the same phase. Current is also in the same phase. V and I are in phase. The angle between voltage and current pi is equal to 0 degrees. Pi is equal to 0 degrees. Whenever if the voltage V is here, the current is also in the same phase I is here. So the angle between voltage and current is equal to 0 degrees. How much, ma? 0 degrees. Now if you see here, all of you, I hope you are following, ma? Right, Chana? Now, what do we understand? What do we understand here? Come to this. What is the power factor formula? Power factor is equal to cos pi, Chana. Power factor is equal to cos pi. Now, what is pi? Angle between voltage and current. Cos 0, that is equal to 1. In a pure resistive circuit, the current is given by I is equal to V by R. Angle between voltage and current is 0 degrees. Power factor is maximum, that is equal to unity. That is equal to unity. Now, what is the power formula in a AC circuits? Power formula in AC circuits. P is equal to VI cos pi. Already I told you, just now I told you. VI cos pi. What is the cos pi value? Is 1. In this case, it is 1. So, whenever cos pi is 1, power P is equal to VI only in the case of pure resistive circuit. Now tell me, ma, what are the important conclusions we taken from a pure resistive circuit? What are the important conclusions we can take from a pure resistive circuit? Can you tell what are the conclusions here? What are the conclusions here? Number one point, what is that? Angle between angle between P and I is equal to 0 degrees. Number 2 point. This is the discussion in pure resistor. V and I is 0. Current I is equal to V by R. Current I is equal to V by R. Third point. Power factor cos pi is equals to 1. Power factor cos pi is equal to 1. Next. Fourth point. Power factor is different. Cos pi is a power factor. Power is given by VI. Power is given by VI. Now if you see here, see all of you, if the voltage is started like this, it is a voltage waveform. The current waveform also will be the same, but it is in phase. Magnitude may be differ. This is the voltage, it is the current. So angle between voltage and current, they are in phase. It is for the pure resistive circuit. It is for the pure resistive circuit. Clear, all of you? These are all the points related to the pure resistive circuit. AC supply is given for a pure resistive circuit. These are the conclusions for the any difficulty you are following? I am trying to cover the only important concepts, because of the short time. We have only maximum of 1 month time. We will plan to complete our syllabus within a 1 month, so that as per the examination point of view, what areas we have to cover, that I am going to discuss. Can I shift to the next topic? Right, Chana? Conclusions you are taken? Right, ma. Next. Coming to the pure inductance alone. This is a very, very important. We have a pure inductance L. It is in Henry. Units are Henry. The supply voltage V. Supply voltage V of t is equal to Vm sin omega t applied. V is equal to Vm sin omega t is given. Now, right, Chana? It is the current flowing here I. What is that? Current flowing I. What is the current formula in inductor? I is equal to, just you recollect your information, your past information. I is equal to 1 by L integral of V dt. I is equal to 1 by L integral of V dt. Now, what is the current I, ma? I is equal to 1 by L integral of, what is our voltage? V is nothing but Vm sin omega t. Vm sin omega t dt. So Vm is a constant. We can take outside Vm divided by L. Sin omega t, integration of sin omega t is a minus cos omega t. Minus cos omega t upon omega. That is equal to, what do you write, ma? Minus Vm upon omega L cos omega t. It is called the current I of t. Now, hello, current I of t is equals to minus Vm upon omega L cos omega t. That equation only I written here. But when you check your trigonometrical fundamentals, minus cos omega t can be written as sin omega t minus 90 degrees. So this is what we want to substitute in the above equation. Now what is I of t is equals to? Vm upon omega L minus cos omega t. Can be written as sin omega t minus 90 degrees. Are you okay, ma? Minus 90 degrees. Now, sin omega t minus 90 degrees. Now, how to write I of t is equals to? I of t is equals to Im sin omega t minus 90 degrees. Now you tell me, ma, what is the current formula Im? Where is our Im? This is our Im. In this Im, we have this place. Sin omega t minus 90, sin omega t minus 90. What we have here? What is the formula? Im is equals to Vm divided by omega L. Vm by omega L. My dear students, what is Im? Is a maximum current. What is Vm? Is a maximum voltage. Suppose if I want to write I is equal to V by omega L. Both are same, but in this case, maximum current, maximum voltage. RMS current, RMS voltage. Sir, what is omega L? What is the units for omega L? What is omega L? What is the units for omega L? Omega L is nothing but a inductive reactance. Omega L is nothing but a inductive reactance. What is the units for omega L? The units for omega L is ohms. The units for omega L is ohms. Why it is ohms, ma? Why it is ohms? Because current I is equal to V by R. Instead of R, we got omega L. R and omega both are the same properties. The R is opposing the current, omega L is also opposing the current. Omega L is also opposing the current. Hence, omega nothing but 2 pi f. L is L. This can be written as omega L. It is denoted as XL. It is denoted as XL. So, XL is nothing but 2 pi FL, which is equal to omega L, whose units are ohms. Whose units are ohms. Now, okay, ma? Now, coming to here, voltage V is equals to, already V supplied, V is equal to Vm sin omega t. Current I is equal to Im sin omega t. See here, minus 90 degrees. Now our subject will start from here. Actual subject will start from here. See, what is the angle between voltage and current? Voltage is having sin omega t. Current is having sin omega t minus 90 degrees. Here, the voltage and currents are not in phase as like resistance. In this case, the current is lagging by 90 degrees. The current is lagging by 90 degrees. Now see here, all of you. Voltage is here, ma. It is the reference. Voltage V is the reference. Now where is the current I? Minus 90. This is 90 degrees. It is the current I. It is the 90 degrees. Who is first? First is the voltage. After 90 degrees current is appeared. That's why current is lagging by 90 degrees in a pure inductive circuit. The angle between voltage and current in a pure inductor, angle between voltage and current in a pure inductor, pi is equal to 90 degrees. How many degrees? 90 degrees. It is 90 degrees. And current is lagging by 90 degrees with that of voltage. Now, if you want to calculate the power factor, power factor is nothing but cos pi. Power factor means what, amma? Cos pi. Now, what is pi here? 90 degrees. I think you know very well, cos 90 is equal to 0. Cos 90 is equal to 0. Now, what is the power formula? P is equal to VI cos pi. In AC circuits, power is given by VI cos pi. V into I into cos pi is 0. Power is equal to 0. It is the very important question in the exam is concerned. Either for AE or JE, the first important objective question in our class is the power in a pure inductor is 0. The power dissipated in a pure inductor is 0. The active power in the pure inductor is 0. Because inductor is a reactive element, it is not a active element. Inductor and capacitor are the reactive elements. There is no active power here. Only reactive power is there. Now, what are the important conclusions here, ma? In a pure inductive circuit, what are the important conclusions? Can we write the important conclusions for this? What are the important conclusions here? Number 1 point. Current formula I is equals to V by, what we have to write? XL. V by, what is this? Omega L. V by 2 pi FL, all are same. Current formula is this. Current formula is this. Second one. What is the angle between voltage and current? Phi is equal to 90 degrees. The current lags by 90 degrees. Lags by 90 degrees. Suppose if you have the current is the reference, voltage leads by 90 degrees. Voltage leads by 90 degrees. Next, third one. The power factor. What is that? The power factor cos pi is equal to 0. Power factor cos pi is equal to 0. Fourth point. Active power P is equal to 0 watt. So reactive power Q. Reactive power Q formula is what? Vi sin pi. That is V into I into sin 90 degrees what we have. That is equal to Vi. Reactive power is Vi. Active power is 0. Power factor is 0. Angle is 90 degrees. The current is given by I is equal to V by 2 pi FL. V by 2 pi FL. Sir, what are the objective questions possible here? What are the objective questions possible here? What are the objective questions? The most important objective question here is, I already told you, the active power dissipated in a pure inductor is 0. It is the very important question. Very important question. And current is lagging by 90 degrees. Current is lagging by 90 degrees. Current formula. Now, what is the question here is, whenever the frequency increases, suppose, whenever if the frequency increases, what happened to the inductive reactance? Whenever frequency increases, what happened to the inductive reactance? Increases, decreases, remain same, something like that. So, XL is equal to 2 pi FL. XL is equal to 2 pi FL. So, what happened now? When frequency increases, inductive reactance is also increases. It is an objective question. It is an objective question. Next, what is next? When frequency increases, what happened to the current in a inductor? What happened to the current in a inductor? Current in a pure inductor. Tell me, Amma, what is the current in a pure inductor? Now here, the current I is equal to V divided by 2 pi FL. V by 2 pi FL. When frequency increases, current decreases. When frequency increases, current decreases in a pure inductive circuit. When frequency increases, inductive reactance increases. When inductive reactance increases, current decreases. These are all the objective questions possible in case of a pure inductive circuit. Up to now, what we discussed, you got an idea? You got a clarity, ma? How the objective questions? The most important question is, power in a pure inductive is 0. Power is nothing but active power. Try to give the response, amma, how your discussion. Whatever I discussed up to now, it is clear for you. So after the individual circuits, we are going to get the RL circuit. There is a plenty of questions are possible in RL circuit. We can guess a question from the RL circuit in our exam. Give me some response, how you are following, whether you are following, because I am not seeing you, just I am assuming you are following my class. Up to now it is clear, ma? Right, ma. Okay? Right, ma. Next to I will ask a small question for you. This is about what exactly we discussed for the pure inductive circuit. This is what the complete analysis for a pure inductive circuit. So we are taken pure inductor. In a current formula we written, from that current equation is found, angle between voltage and current formula, power factor, power, and conclusion points from this. In case of pure resistor, in pure resistive circuit, if the frequency is increases, what happened to the current I? They will ask like that. If the frequency increases, what happened to the current I? Such a question they will ask you. So, in case of pure resistor, our current formula I is equals to V by R. Current formula I is equal to V by R only. Here, there is no frequency factor. There is no frequency factor. What happened? If no frequency factor means what happens? The frequency increase or decrease, current remains constant. Current remains constant. In a pure resistor, the current is independent of the frequency. The resistance is independent of the frequency. That is what it is. Yes, exactly. Exactly, ma. Right, Chana. Right. Very good, ma. Very good. Next, coming to the pure capacitance alone. Pure capacitance alone. Only capacitor. Only capacitor. It is the capacitor C. It is in farad. Farad. We are given a voltage of Vm sin omega t. Vm sin omega t. Capacitance C. Now go back to your fundamentals. Go back to the fundamentals. The current I in a capacitor is C into dV by dt. C into dV by dt. Is it clear? It is the current equation in a pure capacitor. Current equation in a pure capacitor. Now, current I is equals to C into d Vm sin omega t divided by dt. We have to differentiate this Vm sin omega t. Differentiate. What you are going to get? Current I is equals to C into differentiation of Vm sin omega t. Vm is a constant. Sin omega t is nothing but cos omega t into omega. Hello? What we have to write? Current I is equal to Vm omega into C multiplied na. I can write as 1 by omega C. This is Vm into omega C only. What is this one? Cos omega t. How to write cos omega t? Cos omega t can be written as in terms of sin omega t plus 90 degrees. Pi by 2 is nothing but 90 ma. Pi means 180 degrees. Pi means 180 degrees. Right, Chana? Pi means cos omega. Now, what is the current equation we can write? I is equals to Im sin omega t plus pi by 2. Plus pi by 2 is nothing but a 90 degrees. Plus pi by 2 is nothing but a 90 degrees. Now, what is the V equation, ma? What is the V equation? V is equal to Vm sin omega t. V is equal to Vm sin omega t. I is equal to Im sin omega t plus 90. If you want to draw the vector diagram for this, our voltage is here, ma. It is reference. Voltage is the reference. Where is the current I? Current I is equal to here like this. 90 degrees leading. It is 90 degrees. It is the current I. Now, angle between voltage and current here also 90 degrees. Now, tell me, what are the conclusions here? What are the conclusions here? current formula I is equal to, what is the current formula? V by XC here. This is IM. IM is equal to VM by XC. What is XC? What is XC? 1 by 2 pi FC. 1 by 2 pi FC. 1 by 2 pi FC. Whose units are ohms? Whose units are ohms? Now, what is the angle between voltage and current pi? Angle between voltage and current pi is equal to 90 degrees. What is the power factor? What is the power factor? Power factor is equal to cos 90. Power factor is equal to cos 90. That is equal to 0. That is equal to 0. Next, what is the power P? What is the power P? The power P is equal to VI cos pi. VI cos pi, that is equal to 0. These are all the conclusions in a pure capacitor. These are all the conclusions in a pure capacitor. So, what is the important, Amma? The power in a pure inductor is 0. Power in a pure capacitor is 0. Power in a pure inductor is 0. Power in a pure capacitor is 0. Because inductor and capacitor are the reactive elements. Are the reactive elements. Now, what are the questions we can get? Objective questions we can get here. What are the objective questions we can get here? In this case, XC is equal to 1 by 2 pi FC. XC is equal to 1 by 2 pi FC. When frequency increases, capacitive reactance decreases. When frequency increases, capacitive reactance decreases. Next, what is the current formula? IC, current in the capacitor. IC is equal to, what do we write? V by XC. V by XC. That is, IC is equal to V by 1 by 2 pi FC. IC is equal to V into 2 pi FC. Here what happened? Here what is the observation? When frequency increases, current is also increases. Frequency increases, current is increases. Are you clear? So, in the case of inductor, when frequency increases, current decreases. In case of resistor, when frequency increases, current is independent of the frequency in resistor. Here, frequency increases, current increases. So, these are all the, here, frequency increases, capacitive reactance decreases. This is one important objective. It is another important objective. Most important objective question is, power in a pure inductor or pure capacitor is 0. Power factor is 0, power is also 0. How the angle between voltage and current is 90 degrees, but here current is leading by 90 degrees. Current is leading by 90 degrees. Right, China? Very good, ma. Very good. Now, see here. Now, what I'll tell you. voltage V is equal to Vm sin omega t. Current I is equal to Im sin omega t. Sin omega t. So what is the angle between this voltage and current? Voltage and current 0 degrees. Your voltage is here, current is also here. They are in phase. Suppose if you want to represent in a sinusoidal waves, sinusoidal wave, it is like this. It is the voltage V, this one is the current I. V and IR is in phase. V and IR is in phase. Are you okay? Right, Chana? Now, the voltage V is equal to Vm cos omega t. Current I is equal to Im sin omega t. Now I am asking a question for you. What is the nature of the element present for this given circuit? Option A, resistor. Option B, inductor. Option C, capacitor. Option D, RL circuit. Resistor, inductor, capacitor, RL circuit. For the given voltage and current, what is the nature of the element present? This is you have to answer, ma. I will wait for your answer. I have to check. Yeah. See, ma. So first observation you have to see here. It is in sin omega t. It is also to be in sin omega t to represent. One is sin, other one is cos. We can't say. First of all, that point you have to observe clearly. You have to observe clearly. Now, how to convert this is into your sin terms? How to convert this is into sin terms? Now, see here, this can be written as Vm sin omega t plus 90 degrees. This is the first point. These two are equal. These two are equal. Are you clear? Yes. Are you clear, ma? So, voltage Vm sin omega t. Now, you try to draw the vectors. Now, you try to draw the vector. Where is your current? First, no angle. Hence, current is no angle. I can draw current is here. No angle, current is here. This is the current I. Now tell me, where is the voltage? Voltage is Vm sin omega t plus 90. Plus 90 means here. This is your voltage V. Voltage is here, current is here. Now tell me what is the nature of the circuit. Yes, ma. Exactly. Because if you see here, first voltage is produced, after 90 degrees the current is there. In this case, voltage leads by 90. Nothing but current is in lagging. Current is lagging by 90 degrees with respect to voltage. First voltage is created, then current is created. Current is lagging by 90. Hence, the answer for this one is pure inductor. This type of models we can get in the examination. This type of models we can get in the examination. Clear? Where you are going to commit the mistakes, that I am trying to avoid here. Because in examination hall, where students will do the errors, such errors we can eliminate in our short span of time. Mr. Pavan, inductor. Yes, clear all of you? Clear all of you? Now I think you understand what is the element present in this case. Now, if the voltage waveform is like this, it is the voltage waveform, and we have the current waveform is here. The current waveform is like this. This is the current waveform. Now, by looking this vectors diagram, what is the element here? What is the element here? Now, if you see in this case, we started first. Voltage is started first. When voltage reaches to 90 degrees, the current is started. The current is started. So, current is lagging by 90 degrees. I is lagging by 90 degrees. Hence, it is a inductor. It is a inductor. Clear, ma? It's a inductor. Now, see here, voltage V is equal to Vm sin omega t, current I is equal to Im sin omega t minus pi by 2. Minus pi by 2. Now tell me what is the nature of the element here? In this case, current is lagging by 90 degrees. It is 90 degrees. 90 degrees. Current is started after the voltage 90 degrees. Hence, it is a inductive circuit. Now, what is here? What is the nature of the element? R, L, C, RL or something like that. Yes, ma. Yes, right. Nice, very good. Because current is lagging by 90 degrees, it is a pure inductive circuit L. Pure inductive circuit L. Suppose if the voltage is here, current is here, voltage is here, current is here. Current is lagging by 90, hence inductor. When current is here, voltage is here, voltage is here. Then what happened? Current is lagging by 90 degrees. Here is current is lagging, here also current is lagging. First voltage started after 90. First voltage started after 90. So both are come under the L circuit only. Pure inductive circuit only. Pure inductive circuit only. Nice, ma. Nice. You are answering clearly. Very good. Now, coming to the next one. The voltage V is equal to Vm sin omega t. Current I is equal to Im sin omega t plus pi by 2. Plus pi by 2. V is equal to Vm sin omega t minus pi by 2. Current I is equal to Im sin omega t. Next, V is equal to Vm sin omega t. Current I is equal to Im cos omega t. Now you tell me what is the nature of the circuit for this. What is the nature of the circuit for this? What is the nature of the circuit for this? Option A, resistor. Option B, inductor. Option C, capacitor. Option D, RL or RC circuit or something like that. So each, this one is belongs to what? This one is belongs to what? This one. 3 questions are here, ma. 3 questions are there. Now tell me what is the nature of the circuit. It's a pure inductor, pure resistor, pure capacitor. Like that you want to answer. If you are able to, if you can able to draw the vectors, if you can able to draw the vectors, the answer becomes more accurate, ma. There is no mistake you are going to get. Try to think of it. These are all very, very important questions, ma. Yes. Okay. All are capacitive nature. All are is in capacitive nature. Because, see here, how we are going to get Vm sin omega t. Vm sin omega t. This is V. Where is current? Im sin omega t plus 90. This is your current I plus 90. So current is leading by 90 degrees. Hence it is a pure capacitor. Clear? Next, where is voltage? First you take current is here. It is reference. This is the current I. Where is the voltage? Minus 90 like this. Voltage is here. So who is first? Current is first after 90 degrees voltage. Hence current is leading by 90 degrees. Hence it is pure capacitor. Pure capacitor. Vm sin omega t. Okay, it is in sin omega t. But it is in cos omega t, na? We have to convert into sin omega t. How to get this one? Im cos omega t can be written as sin omega t plus pi by 2. Sin omega t plus pi by 2. Now what happened? Sin omega t plus pi by 2. What happened? Vm sin omega t is here. This is V. Where is current? Sin omega t plus 90. This is current I. Hence it is a capacitor. It is also a capacitor. Current is leading. Current is leading. Current is leading. Totally 90 degrees leading. Hence it is the pure capacitive circuit. All are the capacitive circuits. Now we got an idea. By knowing the equations, by vector diagrams, we are able to identify the given circuit is a R or L or C. I hope you all are following very clearly. Now, you take the pure resistance, pure inductance, pure capacitance. Just we will conclude how these elements are there, how the properties. Right, Chana? Resistance, inductance, capacitance. Now, what is the impedance for the each element? Impedance is nothing but it is a resistance which opposes the current in AC circuits. It's like a resistance. Here only we have arm. What is here? Inductive circuit which will oppose the current. That is XL na? And what is the capacitive circuit? XC. XL is equal to 2 pi FL. XC is equal to 1 by 2 pi FC. All are having units of ohms only because of impedance. All are having impedance only. Now, how to calculate the current here? How to calculate the current here? Current I is equal to V by R. I is equal to V by XL, V by XC, V by 2 pi FL, V into 2 pi FC. Why I am writing all these things? Because there is an objective question here. Whenever frequency increases, the current is increases. That circuit is a capacitive circuit. Whenever frequency increases, current is decreases. That circuit is an inductive circuit. All these points already we discussed. Now, Seema, don't confuse for the reactance and current. XL is equal to 2 pi FL. When frequency increase, inductive reactance increase. But current is decreases. Be careful about that point. Now, what is the angle between voltage and current? Angle between voltage and current. How much angle in resistive circuit? 0 degrees. Here, 90 degrees. That too current is lagging. That's why I write as lag. Capacitive circuit, 90 degrees leading. 90 degrees leading. Now, what is the power factor cos pi? Cos pi. Pi already you know. This is 1. Unity power factor. The power factor is 0 lag. The power factor is 0 lead. 0 lead. What happened to the active power, ma? What happened to the active power? You know, active power formula is VI cos pi. VI cos pi. What is the active power here? VI. See, my dear students, the maximum power only this. You cannot get more than this power in any circuit. Maximum power is possible in pure resistive. But one more important point is, whatever voltage and currents are here, they are RMS values. They are RMS values. Suppose if you write power is equal to Vm into Im, that is a wrong. Don't write as a Vm Im, because Vrms, Irms is the power. Next, what about the power here in a pure inductive circuit? That I already told you, this is the very, very important question. 0. Power in a pure capacitive, 0. Now, what is the reactive power, China? What is the reactive power, Amma? Pi sin pi. 99% they will ask the question active power only. Only additional information we are talking here. When pi is 0, sin pi is 0, reactive power is 0. Because resistor is not a reactive element. Inductor is a pure reactive element. Hence, sin pi, sin 90 is 1. Reactive power is Vi. What about here? Reactive power is Vi. Sin pi is 1. Reactive power. Of course, apparent power for all the cases, Vi, Vi, Vi only. Complex power is Vi, Vi, Vi only. Now, if you want to see the vector diagrams for this one, for inductor, vector diagrams, if you want to see the vector diagram here, the voltage is here, current is on the same phase. What happened in the inductance? Voltage is here, current is like this. Or if current is here, voltage is here. Both are same. It is 90 degrees only. It's 90 degrees only. Here current is lagging, here current is lagging. Next, what about in this case? When voltage is here, current is like this. Current. This is 90 degrees. And what about the alternative diagram for this one? Suppose current is here, voltage is like this. Here current is leading by 90, current is leading by 90, current is lagging by 90, current is lagging by 90. Voltage and currents are in phase. These are the vector diagrams. These are the vector diagrams. When if you want to see, it is in a sinusoidal wave representation. In a sinusoidal wave representation, if your voltage is here, suppose voltage is here like this, and our current waveforms, The current starts at same point and ends at same point. Current starts at same point. This is the current I. It is the voltage V. Now, where is our current? Current lagging by 90 degrees. Lags by 90 degrees. It is like this. It is the current I. What about here? Current is leading by 90 degrees. Your current may starts here, reaches to maximum, it goes to 0, and it is maximum, it goes to 0. This is what current I, voltage V. It is the vector diagrams. This is at a glance, the differences between R, L and C circuits. R, L and C circuits. Got idea, Chana? You got a clarity? Now, the most important 100% damn sure question which we are going to get from a RL circuit. 99.9% there is a numerical problem, a combination of R and L. Combination of R and L. We have RL circuit, RC circuit, RLC circuit. Their numericals are more important. Problems are important. We have to do the problems in that and take a small break. I hope you must be very relaxed. Don't feel bored. Maximum of 10 minutes is the break. Now it is 11:30. Sharp 11:40 I will start class again with a combination of RL circuit with the numericals. Take a break, ma. 10 minutes is the break for you. right? Now, up to now what we discussed, we have a pure resistor, pure inductor, pure capacitor. Now the combination of resistor and inductor, combination of resistor and inductor, that is called RL circuit. What circuit? Is RL circuit, resistor inductor circuit. We have a resistor here, there is a inductor here, R and L. Now, this is the total voltage V is here. Total voltage V. These two are connected in series, ma. These two are connected in series. Now, I have a small question for you. What is that question is? The voltage across this resistor is 30 volts. Voltage across this inductor is a how much? Suppose 40 volts. It is 30 volts, it is 40 volts. What is the total voltage V? What is the total voltage V? Tell me. These two are connected in series. VR is 30, VL is 40. What is the total voltage V? Generally, you can, L is written, it is in henries. XL is written, that is in ohms. I am waiting for your answer, ma. Give me your answer. It is a very, very, very important topic. Only Shailesh Babu is given. Subbu, I think. Subbu is given. What happened to the other students? Once if you give the answer, you will enjoy more. Right? So here, the voltage V is equal to 50 volts. Voltage V is equal to 50 volts. This voltage is not a 70 volts. 30 plus 40 you cannot write. When V is equal to 70 volts, if you write, then that becomes wrong. It has only 50 volts. Suppose we have a resistor here, a resistor here. 30 volts here, 40 volts here. What is the voltage here? 70 volts. What is the voltage here? 70 volts. We have an inductor here, 30 volts here, 40 volts here, we have a 70 volts here. V1 plus V2, V1 plus V2. But one element is resistor, other element is reactor. You cannot add by directly. It is a vector sum we have to take. We have to take the vector sum. So how to take the vector sum? How to take the vector sum? Now see here, how to take the vector sum. See some current is flowing in the circuit I amperes. Voltage across this resistor is VR. Voltage across this inductor is VL. VL. What is the currents and how the equations we can write? Now, suppose if the current I is here, where is the voltage across resistor? Current and voltage in a pure resistor, they are is in phase. So that VR is here. Where is the voltage across inductor? In inductor, you know, current is lagging by 90. When voltage means that should be leading by 90 degrees. That should be leading by 90 degrees. Now what is this one? It is leading by 90 degrees. This is called VL. Now what is the resultant? According to the Pythagoras, the resultant is like this. What is the resultant? V is equal to square root of VR square plus VL square. According to Pythagoras, V is equal to square root of VR square plus VL square. Now see in the case of AC circuits, the total voltage V is equal to square root of VR square plus VL square. We can write like that. V can be written as I into Z, because AC circuit, that is equal to square root of VR is nothing but I into R whole square plus VL is nothing but I into XL whole square. Likewise, if you take I outside, what is here? Z is equal to square root of R square plus XL square. It is the impedance in a RL circuit. Now, how you got this 50 volts? I hope you understand. VR is 30, VL is 40. 30 square plus 40 square, square root, it becomes as 50 volts. You have to go for the vector sum like this. Vector sum like this. Now, how to find the angle pi, How to find the angle pi? Whenever, if you want to calculate the angle pi, pi is equal to tan inverse of y component upon x component. What is our y component? Is a XL. What is x component? Is a R. XL by R. XL by R. So, now how much is this angle pi? How much is this angle pi? Angle pi is greater than 0 degrees, less than 90 degrees. So, angle pi is between 0 to 90 degrees lagging. 0 to 90 degrees lagging. It is very, very, very important. They will ask you question in a vector diagram format. In a vector diagram format. Sir, if it is 0 degrees, it's a pure resistive. If it is a 90 degrees, pure inductive. But it is not 0, it is not 90. Between 0 and 90, we have a inductor. Now, suppose your voltage is here. Current is some angle pi is here. Current is some angle pi is here. Now, what is the nature of the circuit? What are the nature of elements present here? What are the nature of the elements present here? The nature of the element present here is RL. First of all, where is the current? Current is lagging by some angle with respect to voltage. But this is not 90 degrees. That's why it is RL. Less than 90 degrees. Less than 90. Suppose I have a current here. The voltage is like this. Voltage is like this. What is the nature of the elements here? What are the nature of the elements here? Here also current is lagging by some angle pi, hence it is a RL circuit. This is RL circuit. Clear, ma? I hope you understand what is this circuit is RL circuit. Because suppose if the voltage is here, current is like this, then what is the circuit? What is the element here? Because of the 90 degrees, it is a pure inductor. Because of less than 90 degrees, it is a RL circuit. Even if you have a current is here and the voltage is here, this is called inductive circuit L. So this is the difference. Here angle is less than 90, here angle is 90. That's why we can able to identify what is, whether it is a RL or L circuit. RL or L circuit. Clear, ma? Clear, all of you? Now, in this case, what is the current formula here? How to find the current formula? Current I is equals to V by Z. This current is a RMS value of current. This voltage is also a RMS value of voltage. I is equal to V by Z. So the current I is equal to V upon square root of R square plus XL square. R square plus XL square. This is the current in the circuit. Now what is the power factor, ma? How much power factor? Power factor is between 0 to 1 lagging. Power factor is 0 to 1 lagging. Now, what is the power formula here? What is the power formula here? P is equal to VI cos pi. This power is called active power. This power is called active power. Power formula is VI cos pi. Power factor is 0 to 1 lagging. Current formula is this one. How the angles are like that. Now, you can see how the voltage and current waveforms. How the voltage and current waveforms for this. How the voltage and current waveforms here. Suppose V is equal to Vm sin omega t. Current I is equal to Im sin omega t. What I have to write here? Think of yourself. What we have to write here? So here we can write the pi. We can write the pi. That too, minus pi we will write. Why minus pi? Because current is lagging by some angle. Sir, it is not 0, it is not 90. It may be 30 degrees, 45 degrees, 60 degrees, something like that. But it is less than 90 degrees. This is the waveform. Or else, current I is equals to Im sin omega t. Im sin omega t. V is equal to Vm sin omega t plus pi by 6, pi by 3 or something like that. Plus pi we can write. This can be written as plus pi. This angle. Now, if you see this one, see here, this is the voltage reference. It is the voltage reference. Now, if you see clearly, voltage is reference, current is lagging by this one. This waveform and this vector diagram, both are same. These equations and this vector diagram, both are same. Coming to the other one, this vector diagram, current is reference, voltage is leading. Current is reference, voltage is leading. These two diagrams are, this equation and this diagram are same. These equations and these diagrams are same. The case of RL circuit. Clear, Chana? How the equation formats in a RL circuit? Now, coming to the power, we have three powers. One is active power, other one is reactive power, one more is apparent power. This apparent power is also called as a complex power. This active power is also called as a real power. It is also called as a true power. Active power, real power, true power, all are belongs to the same. There are three powers are available in the circuits, in AC circuits. The active power is given by Vi cos pi. The reactive power is given by Vi sin pi. The apparent power or complex power is given by Vi. These are all the three powers. Hello. Now, already I'll write one more equation for this. Now, sometimes we are writing the power is equal to I square R ma. Power is equal to I square R. My question is, this I square R is equal to Vi cos pi or Vi sin pi or Vi? I square R is equal to what? Vi cos pi, Vi sin pi or Vi? This one is equal to among these three. Which one? Tell me. Which is equal to what? Actually, this VI cos pi is equal to I square R only. VI cos pi is equal to I square R only. VI sin pi is nothing but I square X. VI is nothing but I square into Z. Now, how I got this one? How they are equal? Now, in AC circuits, V is nothing but I into Z. I is nothing but I only. Cos pi is nothing but power factor, ma. The power factor formula is R by Z. Power factor formula is R by Z. I hope you know that. Power factor cos pi is equal to R by Z. Now what happened? This Z and Z gets cancelled. We have I square R. I square R. Similarly, how to write the I square? I square X. How can I write this one? V is nothing but I into Z. I means I only. Sin pi means XL by Z. XL by Z. This Z gets cancelled. I square XL. Now here I into Z into I, that is equal to I square Z. This one is also can be written as, V square by R, V square by X, V square by Z, V square by Z. Now, units for this one is watt, units for this one is volt ampere reactive, units for this one is volt amperes. These are all the three powers available in our AC circuits. Three powers available in AC circuit. It is a very, very, very important, ma. Already in the KPTCL exam, last time KPTCL exam, there is a question given in the power triangle. Not in KPTCL exam. Only generation and transmission, that is only the difference. Question given. What is that question? We will discuss now. What is the model of that question? Now, if you come to the power diagram is concerned, we have a active power here. Active power is nothing but always we can write in the x-axis. This is VI cos pi. Reactive power means sine axis. It is the VI sin pi. And resultant is VI. Now, if you want to write here, what is the VI cos pi? It is in kilowatts. If you want to write reactive power, what is that? kVAR. Already we written here. VAR watts. Now what about this one? It is kVA. According to the Pythagoras, how to write kVA, amma? How to write kVA, chinna? kVA is equal to square root of kW square plus kVAR square. It is the very, very, very important formula, especially for our exam is concerned. This is the model question given in the KPTCL exam. Okay, China? Okay, ma, all of you. Now what is the question? Model question is here. What is the model question is here? The model question is, suppose we have a 6 kilowatts here, 8 kVA here, 8 kilowatt. What is the kVA of this? 6 kilowatts, 8 kVA. What is kVA? How much kVA? Very simple question. What is the answer? Yes, ma. Yes, nice. Square root of 6 square plus 8 square, that is equal to root 100, which is equal to 10 kVA. So square root of 6 square plus 8 square, root of 36 plus 64, that is equal to 10 kVA. 10 kVA. Now, I have a 4 kilowatts here, and what is the kVAR? What is the kVAR? If the 5 kVA is here, 5 kVA is here, like that question. 4 kilowatts, 5 kVA, how much kVAR? It is the model, it is the question given in the KPTCL Assistant Executive Engineer exam, AE exam. Yes, Subbu, right, Subbu. Right, SKR. Okay, ma, 3 kVAR. That is square root of 5 square minus 4 square, that is equal to 3 kVAR. 3 kVAR. 3 kVAR. Now, these are the 3 powers available. These are the 3 powers available in the circuit. What are the powers here? These are the powers. Now, there are some factors here. What is cos pi. If you have a impedance triangle is here, this is the impedance triangle. It is always active component resistance. It is the reactive component XL. It is the impedance component Z. Impedance component Z. So then Z is equal to, you know, root of R square plus XL square. It is the angle pi. It is the angle pi. What is cos pi? What is sin phi? What is tan phi? Cos phi is nothing but a power factor. Cos phi is nothing but a power factor. Sin pi is nothing but a reactive factor. What factor it is? Reactive factor. Yes, ma. What about this tan pi? What about this tan pi? Cos pi is power factor, sin pi is reactive factor. What is tan pi? Hello, don't tell it is apparent factor. This one is a quality factor. This one we call as a quality factor. This is called a Q factor, quality factor or Q factor. Power factor, reactive factor, quality factor. From this triangle, cos pi is equal to R by Z. Sin pi is equal to X by Z, XL by Z or X by Z. Tan phi is equal to XL by R. Tan phi is equal to XL by R. XL by R or X by R you can write. Sir, what are the units for this one? What are the units for this one? In general, for the factors, they do not contain any units. Resistance by impedance, ohms by ohms, cancel. Ohms by ohms, ohms by ohms, no ohms, it is cancel. No units for this because these are all factors. These are all factors. Are you okay? Now, how to define the power factor? There are three definitions for power factor, amma. Power factor. There are three definitions of power factor. What are that? Number one, it is the cosine of angle between voltage and current. Cosine of angle between voltage and current. Number two, it is the ratio of resistance to impedance. It is the ratio of resistance to impedance. That is, cos pi is equal to R by Z. One definition is cosine of angle between voltage and current. Second definition is ratio of resistance to impedance. What about the third one? What about the third one? It is the ratio of active power to apparent power. Sorry, that's it. Active power to apparent power, which is equal to active power upon apparent power. Apparent power. So what is active power formula, Emma? Vi cos pi. What is apparent power formula, China? Vi. So Vi gets cancelled. We have only cos pi is there. These are all the three definitions for the power factor. Power factor is cos pi. It is very important for electrical engineering. Quality factor is more important for electronics communication engineering. Electronics communication engineering. Yeah. Right, Chana? So what we discussed? What are the various powers in the circuit? What are the various powers in the circuit? And based on the angles, how the circuit, and what is the vector diagrams for this? All these things we discussed. Now, what is the conclusions for this? What is the conclusions for RL circuit? For RL circuit, what are the conclusions? Current I is equals to V divided by Z. Current I is equal to V divided by Z. Nothing but V divided by square root of R square plus XL square. R square plus XL square. Next, what is that? Phi angle is greater than 0 degrees, less than 90 degrees, lagging. Power factor cos pi is greater than 0, less than 1. Greater than 0, less than 1. What is the active power formula? Active power formula, P is equal to VI cos pi. P is equal to VI cos pi. And how the angles we discussed. Already vector diagrams we discussed. Now, the most important problem we are going to discuss for the examination point of view. This is what we can expect a question from the exam. V is equal to 100 sin 314t. Current I is equals to 10 sin 314t minus pi by 6. Minus pi by 6. This is the voltage and currents given in the circuit. Voltage and currents are given in the circuit. Number 1, find number 1 frequency. In the circuit, what is the frequency? Number 2, nature of the circuit. Nature of the circuit. Number 2. Number 3, what is the impedance Z? Number 4, what is the power factor? PF means power factor. Number 5, what is the resistance in the given circuit? Frequency we want to find, nature of circuit, impedance, power factor, or number 6, active power. Active power. Number 7, reactive power. Number 8, apparent power. Number 9, what is the value of inductance L? What is the value of inductance L? These are all the 9 questions from this given data. Voltage and currents are given. We want to find all 9 questions. 9 problems are there from this data. We have to find it. Right, Chana? Clear, ma? How the questions are? Okay, ma? Number one question, we want to find the frequency. So from this we can find the frequency. Omega is equal to 314. 2 pi f is equal to 314. F is equal to 314 divided by 2 into 3.14, that is equal to 50 hertz. Already we discussed. Yes or not? 50 hertz. Next. Nature of the circuit, ma. What is the circuit we have to find? Nature of the circuit. Here voltage is the reference. Current is lagging by 30 degrees. So voltage is here, number 2. Voltage is here. Current is lagging by 30 degrees. This is 30 degrees. Current I. So whenever current is lagging, there is a inductor. It is not 90 degrees, hence it is a RL circuit. This is called RL circuit. This is called a RL circuit. Next, we have to find the impedance Z. We have to find the impedance Z. Third one, Z is equal to, how to write, China? V by I, ma. Z is equal to V by I. Very good, ma. Somebody has given. Okay. Z is equal to V by I. So here V by I means V by I, but it is a VM, it is a IM, not RMS values. This also can be written as VM by IM. Both are same. If these two are maximum, if these two are RMS, it's not a problem. Now, 100 by 10, no, that is equal to 10 ohms. Z is equal to 10 ohms. It is a very, very important question. Z is equal to 10 ohms. Are you okay? Next. Next, power factor. Teach na. How to find the power factor? How to find the power factor? How to find the power factor? As already we know, the power factor is the cosine of angle between voltage and current. Cosine of angle between voltage and current. What is the voltage angle, ma? What is the voltage angle, Chinna? 0. Already we written. 30 degrees is the angle. Hence, our power factor is cos 30. Power factor is equal to cos 30. Cos 30 is equal to how much? Root 3 by 2. Root 3 by 2. That is equal to 0.866 lagging. 0.866 lagging. That is over. Next. This is over. Next. Resistance we want to find. How to find the resistance? We know formula for power factor cos pi is equal to R by Z. Z already we found, cos pi already we found, we can calculate the R. R is equal to cos pi into Z. What is cos pi? Root 3 by 2 into Z is how much? 10. That is 5 root 3 ohms. 5 root 3 ohms. It is over. What is over? Clear ma? Clear all of you? 5 root 3 ohms. Next, China. Next. What we want to find? What do we have to find? See here. Here we have to find the active power. Sixth one, active power. It is a very, very, very important question. Active power. So what is the active power here? Vi cos pi. Vi cos pi. That is equal to how much V ma? 100. How much I china? 10. What is the cos pi amma? Root 3 by 2. If you write like this, your answer will goes to wrong. Because this voltage is a VRMS, this current is a IRMS. So that we have to write root 2 is here, root 2 is here. Be careful about this point. In your KPCL exam, you can guess this question. You can expect this question. Now how much it is? 1000 by 4, 250 into root 3. 250 into root 3. That is the answer. Next to reactive power. Reactive power is how much ma? Vi sin pi. Reactive power is Vi sin pi. Reactive power is equal to 100 by root 2, 10 by root 2, sin pi. Sin pi is how much? 1 by 2. This is equal to 250 watt. 250 VAR. 1000 by 4, 250 VAR. Apparent power, V into high. So that is 500. How much ma? 500. 100 into 10 divided by root 2, that is equal to 500 volt amperes. Active power, sorry, apparent power is Vi, that is equal to 100 by root 2 into 10 by root 2. Clear, Chana? Okay, ma? Active power, reactive power, like that. Next, how to find the L? How to find the L? This is also important, but I will tell you the procedure. For this, you need a calculator, but anyhow, you have to know the procedure. What is the procedure for this? What is the procedure for this? If you want to calculate L ma, if you want to calculate L, you should know XL. Should know XL. XL is equal to 2 pi FL. XL is equal to 2 pi FL. XL is equal to omega L. So, what is Z is equal to? Root of R square plus XL square. What is XL is equal to? Root of Z square minus R square, that is equal to square root of Z is how much? How much Z is there? 10 square minus R is how much? I think R is how much value you got R? Cos pi, I think 5. I hope it is 5. Resistance value is 5 root 3. 5 5 root 3 whole square is equal to XL. After finding the XL, you have to substitute here. XL means L is equal to XL divided by 314. Generally calculator is required, but I told you the procedure, amma. These are all we have to calculate. Okay, ma? Okay, all of you, my dear students, clear about this problem? Right? All of you taken this? At a glance, if you want, you can go through this. The problem, what we solved. We solved 7, 8 is here. Apparent power. 9th one is XL. 9th one is XL. Next to the current I is equals to current I is equal to 10 root 2 sine 1000 t. 10 root 2 1000 t. And voltage V is equal to 50 root 2 cos 1000 t minus 30 degrees. Again we have to find alma. What do we have to find? Find Z, R, power factor cos pi, active power, reactive power, apparent power. Likewise, if you want to calculate all these things. Power factor, Z, R, cos pi, all these things we need to find for the same problem. This problem is homework for you. You can do it. Don't spend time here. You can prepare in the break or something like that. I'll give some more models. Meanwhile, this problem you have to do. What is the problem here? In this problem, one is sine, other one is cos. It should be very important point. If you want to convert this cos into sine, that is required. Directly you can't do. Pi is 30 degrees, don't do like that. So, how to convert this? V is equal to 50 root 2 sine 1000 t minus 30 plus 90 degrees. Plus 90 degrees. Now, what happened here? 50 root 2 sine 1000t plus 60 degrees. It is the original equations. Voltage equation is this one. Current equation is this one. Now you start according to your procedure. That is the important observation we have to see here. Okay, Chana? Now here you follow your procedure. Whatever steps we made for the previous problem, same steps we can go. First of all, it is RL circuit or not? That we have to identify whether it is RL circuit or not. How do you? Current is here. Where is your voltage? Plus 30, plus 60. This is voltage. Angle between this voltage and current is 60 degrees. Who is lagging? Current is lagging. Lagging by how much? 60 degrees. That's why it is the what circuit? It is a RL circuit. Now you know, find the power factor. Angle you know, power factor, cos 60. Cos 60 is nothing but 1 by 2, 0.5 lag. From that, Z is equal to 50 root 2 by 10 root 2. Root 2 root 2 gets cancelled. 5 ohms. Z is equal to 5 ohms. Z is equal to 5 ohms. Cos pi is equal to, enta? Cos 60. Cos 60 means 0.5. Lagging. R is equal to 2.5 ohms. Directly you are getting all these things. VA cos pi, VA sin pi, VI. Clear ma? All of you? Next problem we have a 30 ohms here, J 40 ohms is here. Voltage V is equal to 50 at an angle of 0. Voltage V is equal to 50 at an angle of 0. What is the total power dissipated? Power dissipated in the given circuit. The given circuit. What is the total power dissipated in the given circuit? Tell me what is the answer? I am waiting for your answer, ma. I will explain. Give me answer. Right, Amma? Here, the total power P is equal to I square into R. Total power I square into R. Because the power is not dissipated in the inductor. Power is dissipated only in the resistor. What is the current formula? I is equal to V divided by Z. V is how much, China? 50. What is the Z value, ma? Root of 30 square plus 40 square. That is equal to 1 ampere. 50 divided by 50, 1 ampere. What is the power formula? I square into R, that is equal to 1 square into 30, that is equal to 30 watt. Sir, you may have a doubt, sir, why you are not writing VI cos pi, sir? You can write VI cos pi also. You can write VI cos pi also. Same answer we will get. What is the V? 50. What is I? 1 ampere. What is cos pi? Cos pi is a R by Z. R by Z. 50 into 1 into R is how much? 30. What is Z, China? Z you calculated 50. So 50 gets cancelled. What we have? 30 watt. These type of models and examples we can guess in our exam. Now, is the voltage we have. There is a resistance of 10 ohms here, inductance of 1 millihenry here, 1 millihenry here. V of t is equal to 100 sin So here what I'll give, this value of inductance 0.1 Henry, 100 sin 100 t volts. V of t is equal to 100 sin 100 t volts. What is the current I of t equation? This is the important question. Very important model it is. So see here, if you want to write the I of t, if you want to write the I of t equation, first of all, You try to find what is ZMA. Current I is equal to V by Z. Current I is equal to V by Z. If you want to find yes. Right, Chana? Here what happened? I is equal to V by Z ma. Z is equal to root of R square plus XL square. Here L value is given, not XL value. How to find XL is equal to omega L? Omega how much given? 100 sin omega t. Omega means 100. 100 is given. 100 into 0.1, that is 10. So Z is equal to root of R square plus XL square, 10 square plus 10 square, 10 root 2. Angle is how much? Tan inverse of y component by x component, 10 by 10. Tan inverse of 1 is how much? 45 degrees. 45 degrees. Now, how to write the current equation? How to write the current equation? Now, if you want to write the current equation here, I of t is equal to 100 divided by impedance 10 root 2 sin 100t minus pi by 4 45 degrees. How you got pi by 4? Because of 45 degrees. Sir, why minus? Because of the inductor. Because of the inductor is current is lagging by some angle, that is 45. That is equal to 10 by root 2 sin 100t minus 45 degrees. That is 7.07 sin 100t minus 45 degrees. This is the current I of t equation. Whatever three problems I told you in this RL circuit, there is a damn sure question, one question we can get in the examination. Okay, ma? So this is about RL circuit. In the tomorrow class, I am going to teach you RC circuit, RLC circuit, resonance, series and parallel resonance. That I will complete within a 2 hours class. It will give a full idea about the AC circuits. You are going to expect the 3 marks from this topic. And in the afternoon, at 2 o'clock, Shaker sir will take a class for you. I think he will teach magnetic circuits. Magnetism and magnetic circuits he will teach you. And because you have short span, you have to attend for the classes as well as you have to prepare well for the remaining time. Okay? Clear, ma? Try to join the class at 2 o'clock. Rajshekhar sir will take the class for you. Tomorrow, I will take the electrical circuits once again, continuity of this topic. So, actually today we conducted this class in YouTube because of some technical problem. But tomorrow onwards, your class will be there from the SAIMEDHA Gate Play Store. App is there, SAIMEDHA Gate. Please take download and join. Of course, automatically during the admission process, they will tell you. Already we joined students, they attended for the SAIMEDHA Gate app only. Tomorrow onwards, today only we YouTube, amma. Tomorrow onwards, you for 2 o'clock class, you can come to the video, this YouTube class only. Same link. Right, Chinna? Okay, all of you. Bye, ma. Bye. Good day. Shaker sir will take in the next session.